So here we've got a question that's got logs involved. And it says, given that 2 log base y of x plus 2 log base x of y equals 5, show that log base y of x is equal to 2 or a half. Now, you'll probably need to use your log rules of some description. And so there's the 2 in front, and you've got log and so forth. But what you might want to recognize is you've got log y of x here. That seems okay. Now, what seems a bit more annoying is over here, you don't have log base y of x, you've got log base x of y. So the part that's bracketed in red is not the same as the part that's in blue. And you're asked to find not x and not y, but log base y of x. So you're trying to find the red thing. Okay. So you're trying to solve for that equals 2 or a half. So with that in mind, we might want to think about how we might approach this question. And given that this is something we're trying to solve for, we might let that be, let's say, a, okay? Just make it easier. And if we could somehow express this in terms of a, then that might help as well. So if we let a equals log base y of x, and well, what does that mean? It basically means y to the power of a equals x. If that helps you think about it, that's what that means. And another way to express that is using your change of base laws, is log of any base, I've picked base e here, of x over log of y. Now, on that note, if we let this be b for now, and if we let b to equal log base x of y, well, that's really saying, okay, x to the power of b equals y. Now, that's not particularly easy, but if we use the change of base law, we could, of course, make this log of y over log of x. That's how the change of base law works. You take the log of what's inside over the log of the base. And if you compare this a and b, then it should be quite clear that this is log x over log y to the power of -1, or in other words, it's a to the -1. And at this point, it's probably fairly easy to see what we can do from here. Basically, the question has now become a question in a, where you have 2a plus 2 over a, or 1 over a, equals 5. Note, of course, that assumes a is not equal to 0. So we might need to check what happens if a equals 0, but for now, we'll just say, let's solve for that. So we multiply by a, move everything to one side, factorize. That seems to be the factorization. We'll double check. 2a squared minus 5a plus 2. So therefore, 2a minus 1 equals 0, or a minus 2 equals 0, giving you a equals a half, or a equals 2. And that's probably all they wanted to see here. And of course, a is what we're after, so therefore, log base y of x is either equal to a half or 2, as required. Now, I guess we could check. In our example, we've just assumed this is 1 over a, so we're saying a can't equal 0, and that's how we solved it. The question doesn't suggest a equals 0 is an answer, but let's just quickly check it can't be an answer, just to dot all our i's and cross all our t's. So if a was 0, that means we're saying that log base y of x is 0. So if this was 0, let me just put it down here. If a was 0, that implies that x is 1. That means y can be anything and x is 1. Well, would that work? That would mean this is 0. Okay. But then log base 1 of y is not really going to give you much of an answer because 1 to the power of anything is going to be 1. So yeah, that wouldn't make sense. The only way that would make sense if y is also equal to 1, and then 2 would not equal to 5. So yeah, for that reason, no solutions, no valid solutions to the equation. So indeed, they probably don't need you to sort of check that, but we have checked it. In this case, there are no further solutions there. And so it indeed just 2 or a half. And that's how you do the question.